Hello everyone, welcome back to my channel and I'm Akshaya, pursuing first year engineering in SVC Bangalore. So today I have come up with a topic in the mathematics part, that is the angles and projection, rotation, reflection and contraction. So some of the basic topics, let's get started. Yeah, coming to the introduction to angles and geometric transformation. Angles are formed by two rays that share a common endpoint. Of course, everyone knew about it. Angles are formed by the two rays that share a common endpoint. Geometric transformation involves altering the position or orientation or size of a shape. Yeah, geometric transformation could always or involve in the alternation of the position, orientation, or size of the shape. In this presentation, we will be exploring the concepts of projection, rotation, reflection, contraction, and expansion. Yeah, this was about to the introduction part. Now coming to the projection. Basically, projection view itself, it says projection is the process of extending lines or shapes to a surface or a plane. Yeah, it means the extending of a given line to get a view of it. Yeah, it is often used in creating 2D or presentation of a 3D objects. Yeah, 2D, 3D projections, of course, we'll be using. Yeah, that's what the projection. And projection can be achieved through various techniques such as parallel projection or perspective projection. It could be done in the various or achieved through various forms, that is the parallel projection or any other perspective projection. Yeah, everyone knew about it. So this was about the projection. Now coming to the rotation in the maths, what does it mean? Yeah, rotation is a transformation that turns a shape around a fixed point called the center of rotation. Of course, rotation means it is a transformation that turns a shape. Rotation, of course, it says it is a turn of a shape around a fixed point. If consider a ball, if we keep at the center, that is the fixed point, and it will be rotating. Yeah, that is what's the rotation. It's point called the center of rotation. Yeah, angle of rotation determines the amount and direction of the turn. The important point I've mentioned here, that is the angle of rotation determines the amount and direction of the number of turns. Yeah. Basically, rotation always have a clockwise rotation or an anti-clockwise rotation too. That's what. Clockwise and counterclockwise rotations are common types of rotation that everyone knew. These are the similar images have been shown here. This was about the rotation. Now coming to the reflection. Yeah. In mathematics, let's understand what is this. So reflection is a transformation that creates a mirror image of a shape across a line called the line of reflection. Yeah, of course, reflection is a transformation that have been created by a mirror image. Of course, we see our whole image in mirror. Of course, that is the reflection. Is a transformation that creates a mirror image of a shape across the line. Yeah, across the line called a line of reflection. Yeah. Each point on the original shape has a corresponding point on the reflected shape, equidistant from the line of reflection. Each point of an original shape or a given shape has a corresponding point on the reflected shape because it plays a major role from the real image to the reflected image. Equidistant from the line of reflection. Yeah. Reflection can occur horizontally, vertically, or diagonally. So in maths of a particular shape, the reflection could be even can be occur in horizontally, vertically, or diagonally too. And according to the given image, we can see the reflection part, line of intersection, how it shows. Yeah, that's what I'm mentioning. So this was about the reflection. Now coming to the contraction and expansion, of course, that is a part of physics, right? Yeah, in mathematics, we are doing it. So contraction is a transformation that reduces the size of a shape while preserving its shapes and proportions. Yeah, it involves uniformly scaling down all the dimensions of the shape. Contraction means it is the scaling down into of a dimension of a shape. If you consider a shape, you scale down into one particular shape, that is meant the contraction. Yeah, contraction can be described by a scale factor less than 1, indicating the degree of reduction. Yeah, contraction can be described by its scale factors less than 1. Yeah, if it is less than 1, then it's of course a contraction, indicating the degree of the function or reduction. Yeah, that's all the contraction. Now come to the Expansion. Expansion, yes. Expansion is the opposite of contraction in a similar way. Easy to tell. Yeah, what is expansion? It's opposite of contraction, where a shape is enlarged while maintaining its shapes and proportions. Yeah, it involves uniformly scaling up all the dimension of the shape. Expansion can be described by a scale factor greater than 1, indicating the degree of enlargement. Yeah, that's what. It involves uniformly scaling up, but contraction was scaling down. It was in this expansion, it is scaling up all the dimension of the shape, but expansion can be described by a scale factor greater than 1, contraction less than 1, because contraction is dead opposite to the expansion, indicating the degree of enlargement. Yeah. So this was a clear cut about expansion and contraction. Now, examples of angles and transformation. Yeah. Now I have choose this slide to give an idea or expand example of an angle and transformation. Yeah. In a right angle triangle, so of course it is a right angle triangle, the image I've mentioned here. The angles include a 90-degree and the other two angles are acute angles. Yeah. So the right angle I've mentioned as shown and acute angle, except 90-degree, both the other two angles are acute angle. When projecting a cube onto a 2D surface, we can see different angles depending upon the orientation of the cube. Yeah. When projecting a cube, of course, consider a cube. When projecting a 2D way, yeah, or onto a 2D surface, we can see different angles corresponding to orientation of the cube. Through its orientation, we can see cube depending upon its orientation. Yeah. Uh, and now coming to a clock's minutes hand undergoes a complete rotation of 360-degree in 60 minutes. Yeah, consider a clock. Everyone know about it. Is upper hand full one complete rotation it goes. That I have been mentioned here. Rotation of 360 degrees. Yeah, in 60 minutes. Yeah, that was about clear cut about an example of angles and transformation. Yeah, how it get changed and what is the angles or the measurement you can take. Yeah. This was about the examples of angles and transformation. Now coming to the practical applications of these topics. Angles and transformation are essential in various fields such as in architecture, engineering, and computer graphics. As architecture, angles and transformation play a major vital role because they need to give a 2D or a 3D view about the planned project uh, to showcase how the plan would be proceeded or project would come. Yeah, that for that purpose, architecture, angles and transformation plays a major role in architecture. Yeah, as you can see, while constructing a home, they give a plan project as given in a 2D way or a 3D way that how the home comes in first an expectation. Yeah. So angles and transformation are used in architecture, of course, in engineering. In engineering, each and every application have been using widely, and computer graphics, of course. Projection is used in creating accurate maps and architectural blueprints. Yeah, blueprints play a major role. That's what I said. In architecture, they'll give a blueprint of a 3D or a 2D view of their home. That's what the blueprint is. Yeah. Rotation and reflection are employed in computer animation and video game designs. Yeah, of course, rotation and reflection are employed in computer animation. Computer animation, even it also plays a vital role in angles and transformation, rotation and reflection in video games designs. Of course, point to be considered. Yeah, this was about application. So coming to the final summary. Angles are formed by two rays sharing a common endpoint, of course, I mentioned. Projection, rotation, reflection, contraction, and expansion are the geometric transformation. As I said, contraction and expansion. Contraction is the opposite to the expansion. Yeah, that we learned. Projections and rotation. Projection, it plays a vital role in the application that is the architecture or the computer animations. Yeah. Understanding these concepts is crucial for various practical application. By understanding this angles, reflection, contraction, and expansion, it would help for us in a crucial situation for a practical application too. Yeah. So this was about the basic concept ideas I have been added in this slide. Hope you guys like this. Thank you so much, everyone.